Okay, what are we talking about this morning? Well, last week we talked about how to make a database, how to design a database, how to make it so that your data is correct. And we're going to go into that some more this week, give you some more sort of a deeper vision of it. Last week we had three separate scenarios. The patient uh, has test results, the patient has appointments, sees a doctor kind of relationship, and also the overall view of a doctor's office, that set of diagrams together. And the end result was this thing called an entity relationship diagram. And I'm just going to zoom into entity relationship diagrams and tell you more about that, give you a bit better picture of it, give you the idea that you can do these things. We'll try to have some exercises for you so you're prepared for the test, and then also real life, because you will see these things in real life. So the title of this lecture is a bit long-winded. It's conceptual data modeling. So we're not actually touching the data itself. We're talking about the concepts around the data, the structural modeling of data, modeling the structure of data using this thing called entity relationship diagrams or entity relationship modeling. An introduction to that thing. Phew, you think the lecture should almost be over with all those words, but no, there's more to come. So let's see. So the idea, we've got a Benalla clinic, it's a GP practice. The clinic would like to design a database that holds information about the patient's appointments and the doctors. So how do you go about it? It's useful to have a systematic procedure for modeling them and their relationships to go about it. Um, so we want to model the 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 data definitions, the data structure, the structure of the actual tables themselves, and the relationships between the tables. And this conceptual data model is that thing, and the ER diagram is a representation of that thing. And as we saw last week, you can convert an ER diagram easily to a relational model of the data. It can be converted into data, and that's what an ER diagram does. So here's an example of an ER diagram, and this is how it gets converted into a table. So you've got your patient entity table, also known as an entity, and it's the circles around the outside is a way to represent the attributes of that patient. So each patient is an overall entity, a class of things, a collection of things, and one of the things of a patient is a first name, the next last name. A patient has got these attributes, and if you wanted to see it in a table, this is what it would look like in Access. You've got name ID, the primary key, the unique identifier for each line. You've got the first name, last name, address, city, patient, state, province. So that information about patients. And yeah, the table, this picture represents that table. That's how we translate between one and the next. You might have got that from the last week, but this week it's trying to make it more concrete. So an entity, as I mentioned before, is a thing. It's a noun, person, place, object, event, or concept. So it's kind of simple when you think about it as a person or place. Patient, sales clerk, doctor, place, locations, campus would be a list of entities, doctor's office, a list of entities, but they can also be other things like object. You might have an entity for wheelchairs in your database. You might have an entity for that has a list of all the blood pressure machines or scalpels, even, lists of things. Events, a surgery might be an entity. Concept, yeah. Anyway, so it can be more vague than actually a physical thing. Like, for example, a course is an entity you can have, because you can have a list of it. So you put it in a square box, and it's lists of things, generally nouns. So when you're looking at descriptions of things, you see the noun, you see it's got an S on the end of it. You say that's probably an entity. An attribute is a thing inside the entity, a characteristic of the entity. Uh, for example, the student entity has got student ID, student name, and course as attributes of it. It must be of interest to us, to the owners of the data. There's lots of attributes. Shoe size is one of my attributes, but you don't care. You don't want to make a database of it. So you want to have the minimal set of attributes that people care about. We don't want to track things that we don't care about. You don't know what you're going to care about, but the good thing to do is to do the minimum amount possible, and then later on add things on if you need to. But it's an iterative process, and find the minimum possible. The key is the thing that uniquely identifies each instance. So in the table, that would be each row, or each student in this table. That's another word for each row, or each thing. Instance, which uniquely identifies the identity type. So a key for student might be student ID. For you, it might be your student number. So there might be more than one candidate key. So candidate key is something that does uniquely identify it, and you might use it. So for example, in hospitals, UR number might be a candidate key and might be enough to uniquely identify a patient. Student name might be a candidate key, because if they're unique, we know that name is a really crappy candidate key, because people have multiple names that are the same. But if you knew that they were going to be unique, you could say that's a candidate key. Address, yeah, that might work as well. So the key is not as defined as the attributes in the entities. I mean, even that's a bit flexible, yeah. And then you can also come up with your own key. You can have an auto-generated key that you make your own if you can't find a candidate key. So it's yeah. Sometimes it's good to use a key that's already in the database. Sometimes it's good to not use a key in the database. For example, if you were going to take people and allow them to change their UR number, then UR number would be a very bad candidate key. And so almost, yeah, generally in the real world, you auto-generate keys so that you can change the other things, just become attributes, and there can be changed. Yeah, and the primary key is a candidate key that has been selected. So in the diagram, it's underlined. This is the basic symbols. So an entity is this box, relationship is the diamond, an identifier, a key is an underlined circle, and an attribute is just a regular circle. So that's one of the conventions for modeling ER diagrams, and that's what we're going to use in this lecture. So a relationship is an association between the instances of one or more entity types. So, that's a lot of fancy words. So it's the relationship between the tables. So a doctor has completed training. It's an individual doctor. That's an instance of the doctor has completed an instance of the training. So it's and again, that is of interest. So we only store the information that we care about. That's always important. What is the practical value of this particular relationship, of this storage and then does it need to be stored? Do we care about it enough? Do we want to store it away? An association means that some event, some concurrent event has occurred, and there exists some natural linkage between the entity instances. So the doctor has completed the training. This thing has happened, and there is a linkage that the doctor, physical doctor, has completed this physical training. We want to track this. So we create a relationship, call it completed. What's the difference between an attribute and an entity? Well, that's kind of so why can't we just have an attribute called training in the doctor? Why can't we just hang another attribute called training off the doctor? Why is that? Well, because training might be a big complex set of information. The name of the course, the date, the time, the cost, who taught it, then we have to have all this information in the doctor table, and then it's redundant because if two doctors take the same course, they both have this whole collection of knowledge within their table. So instead, we take that data and we put it in the training table. And then each doctor just needs a link to that same training thing, the same training instance. Yeah. So there's three different main types of relationships: one-to-one, one-to-many, and many-to-many. One-to-one is rare. I mentioned that in the last lecture because um, you can often, if you got a one-to-one relationship, you can just combine the tables together. Why not just have them as the same table? Why isn't everything on this side an attribute of everything on this side? There's no reason to have them apart except for administrative, uh, you know, patient uh, patient and patient clinical information, patient radiography information. There's one patient, but we don't. It doesn't make sense to combine them together. One to many is much more common. Uh, uh, a doctor has completed many trainings, but a training. Oh no, that's not such a good example. That's a many to many relationship. So many to many relationships are also common. We'll have a look at them later on. So there's also the degree of relationship. How many entities can participate in a relationship? So the unary, degree 1. So for example, a person is married to person. There's only one entity that participates in this relationship. Now, is married points to two people. In Australia, anyways. Other places in the world can point to more people, and so that's why your database has to be culturally sensitive. But in Australia, it points to two people. A binary relationship has two entities, and a ternary relationship has got three entities. Binary is definitely the most common type of relationship. Between this one entity type, binary, another is another one entity type, but it's a um, it's a one-to-many. So a doctor manages many doctor. I'm a single doctor. I manage many doctors. That's why we've got a one on the one side and one on the many side. But then I'm a single doctor. I'm managed by one doctor, many to one. Another type of unary relationship is a bill of material structure, many to many relationships. Many products are composed of many parts. So I don't know why it says appointment there. That's but a thing has got many components, and each of those has a certain quantity. Binary relationships, so one to one, and you can have one to many relationship in binary as well. And a ternary relationship is a simultaneous relationship between three entity types. So a vendor ships a device to a location, and that has a certain quantity. So the think of it conceptually as a certain vendor ships a certain device to a certain location for a certain number of things, but as the vendor can ship the same device to a different location, so that you end up with a different ships record there. A different vendor can ship the same device to a new location, or so any of these things can change, but the relationship looks at all three of them at the same time. So again, a bit more complex, these ones, and it's I don't expect you to generate those, but it's good to be able to recognize them and describe what they do. Yeah. So you'll notice in this previous picture how quantity was an attribute of the relationship. So before we'd seen that entities have attributes. A doctor's got a doctor's name. A parking place has got a parking place number, for example. Location can have an address. A device can have a part number. Each of these can have attributes. But how is it that this relationship has got an attribute? Well, if there's a many to many relationship, this ends up being a table, and so it has attributes. We call it an associative entity. So it's not an attribute of any entity. It's an attribute of the relationship. So it's how many devices did this vendor ship to this location? Because you can't put the quantity here. It's not the quantity of vendors. It's not the quantity of devices um, because the device can be shipped to many locations, and so you have need a different quantity for every shipping record. It's the quantity that was shipped. It's an attribute of that verb, as opposed to an attribute of these nouns. So it's quite a unique little thing, and you'll see that it's useful. For example, in our previous lecture when we talked about doctor, the doctor and appointment, the appointment might have a date, it might have a time in it. So that's kind of things get stored in there. Yeah. So you could um, you could regard the relationship as quaternary. So it'd be a four-way relationship with quantity as another entity, but because it's only got one attribute, we can just treat it as an attribute of the relationship. And the final ER diagram shows all the unique attributes that's involved in the entire database. So the rules about that is that no attribute should ever repeat across entities. Your attribute should only be in one place in the ER diagram. When you convert it to tables afterwards, you end up duplicating the primary key into the related tables as a foreign keys to join the tables together. But in the ER diagram, there should be no duplication. You should not have the same word on your ER diagram twice, except for maybe has or is as one of the entity relationship names. And relationships has a diamond symbol. So the clinic wants to keep track of their patients, their appointments, what should be chosen as entities in our model. The questions. So the first thing is what type of questions do we want to ask? Do we want to know which clinic owns the database? The clinic wants to keep track of patients. We don't want to know what clinic. We don't want to know where it's located. That's not something we're going to ask the database because there's only one of them. So the rule is there should be many entity instances of any entity type. We don't care about clinic. There's only one of them. We can just go look on Google if we want to find out the address of it. So there should be many of instances. If you want to make a table for something, there should be more than one row in that table. So that's one rule. And then only create the entities that are essential. So one of the queries they're gonna ask is, who are the patients? What patients does this clinic have? How can we find all the patients? Well, we probably could think of patient as an entity type, as a type of entity. There's many instances of this patient, and there's many patients. Yeah. Some of the attributes are going to be patient name, patient address. Why are these not entities? Why is patient name and patient address not an entity? Well, because they're only a single one for every patient. There's a one-to-one relationship with patient, so just include them in patient. Oftentimes, there's multiple things that could be called name. For example, in the database that you were given for tutorial one, assessment tutorial set one, you had many code IDs. They are codes, they are IDs, but it's better to have them distinguished. So one way to do it is to take the first letter and put it in front. P name. In this day and age, you'd probably say patient name and patient address. D name. This ensures that the attributes are not duplicated, so you don't fall afoul of that rule. No duplication of names. We probably want to know about the appointments booked by the patient. Appointment has got an appointment time, an appointment number. A patient can have multiple appointments, but an appointment can only have one patient. So I'm an appointment. How many patients do I have? I'm a single appointment. How many patients do I have? One. So you put the one over there. I'm a single patient. How many appointments do I can have? One to many. So you put an M on this side. These are the attributes of that. These are the attributes of that. Doctors and salaries are important. Uh, so everybody gets a doctor number. That makes sense. And doctors also attend appointments. Uh, so this is an example of how there's multiple ways to do a database. In the last database we made, last lecture, we had appointment as just um, a relationship between doctor and patient, whereas now we're making it a full blown entity. The table works out the same, but it's just a little bit different way of modeling it. Yeah. So the problem, the take home problem is to go home, put all this together into one complete diagram, minimize the number of entities. Uh, every every entity should be linked, and think about the queries, and you'll decide what relationships you need and what relationships you don't as a result of what queries that people are going to ask the database. Um, Yeah, and things to watch out for. Things that you can make mistakes. So it has a relationship. Student has a name. You don't have to use that. You can just include it as an attribute. Uh, if an entity only has one attribute, then usually that attribute can be attached to some other entity. If there's only one instance of something, that's a problem. If you've got ternary relationships, you want to think about the cardinality of it. Think, check it carefully, and um, if you don't want a list of something, telephone number, you only got one attribute, then you don't want to make it an entity. And so, and just a tip is, every time you look at an entity, you think about entity, think about tables. So what is the table going to look like? And then think about ternary relationships instead of two binary relationships to a certain point. And then again, one-to-one relationships can be collapsed. It's like a has a relationship. Um, make sure that all relationships are needed by the system, and especially check loops. So if you've got a triangle, relationship A, relationship B, or entity A, entity B, entity C, and they're all connected up in a relationship, then you can say, is one of these not needed? And then make sure that the attributes are unique. That's what you need to know.